Hi everyone. In this video, I'd like to teach you how to create this 2D terrain from scratch, and I'll be creating the code slowly so you can follow along. And as a quick note, if you don't want to follow along, you just want the code straight away, I'll put it in the description for you. I think I'm using Pastebin at the moment, but I'll hopefully move to Git or something later. We'll be using Perlin noise to create a small 2D grid, and then using those numbers to instantiate this map of small tiles that you can see here. Now it creates a cool terrain effect, so I hope it can be useful to you. So let's begin. Okay, starting with an empty scene, let's create our prefabs first. So under here I'm going to want an empty object called map. Now to keep it simple, I'm just going to have these two objects here. Main camera for looking at the terrain and the map for holding all the tile game objects. Now next I'm going to bring in my tile textures. And here you can see I've got four. I've got forest, hills, mountains and plains. Now my tile sizes for this are 36 by 36 pixels. So if you just select them all and set here pixels per unit to 36. So what that'll do is that'll say 36 pixels per one world unit. So when we use the Perlin noise and we generate a grid of integers, not floats, just integers, they'll match up nicely. So let's turn these, click apply, always forget that. So let's turn these into prefabs. Now if you drag them here, you'll try to create an animation. Now you don't want that. So you'll have to do it one by one, but if you drag them here, as you can see, you'll end up having a random XY coordinate value, and you don't want that, you want 0. So the best thing to do is to drag them up here, and you'll get a nice origin value here. So I'll bring these 4 in. Now you can see it's called text underscore. Now this is my naming convention. I use 3 letters per type, but a text for texture. Now I've got these 4. I'm going to drag these into here to create the prefabs. Plains, mountains, hills, and forest. We do this because the textures are our raw assets, whereas the prefabs are the actual objects we're going to be using in the game world. Awesome, now I can delete these. And I'm going to rename these with my prefab prefix, which is PFB. Cool, so now we have our 4 prefabs and we have our 4 textures. So next, let's jump in and create our script. So I'm going to name it Perlin noise map. Again, I've used my prefix for script. Now this is for ease of use. So for example, if I click on a game object here and I click add component, I can just type my prefix, and they come up nicely here. So that's mostly for me. But you can have anything you want, just be consistent. Okay, so let's open up our script here. And we have this. I'm using Sublime, but you can use whatever you want. Okay, so we won't need the update function because this is going to be a purely click play and it generates the map for you. So let's get rid of that and that. Okay, so the first thing we're going to do here is we're going to create a dictionary, which will be our tile set, and I'll show you why. So this will be a way to give our script access to these prefabs here, so we can use them to create our map later on. Now I'm using integer and game object because I'm going to pair an ID code of the tile with a game object. So 0 will be plains, 1 is forest, 2 is hills, and 3 is mountains. Now as you can tell, that's in order of land elevation, so plains is normally the lowest, and then mountains would be the highest. And it's really helpful to keep them in order when you're using a random noise. So because there's only 4, I'm going to type them out here. So game object, prefab, plains, forest, hills, and mountains. Great, so we have our slots here for these to stick into. Let's attach our Perlin noise map script. Wait for it to build. Our Perlin noise script to our map game object here. And now you can see we've got these lovely slots here. We're going to just stick these in. So forest, hills, mountains, and plains. Now I could, in this script here, I could reference these instead of actually having to attach them here. But if I rename them here, then this will automatically be updated for me. Whereas if I rename them and I'm using the script here to find them by name, then I will have to update my script. Every string that references will have to update. So here at least it protects me from renaming. Okay, so now we have our prefabs here in the code. Let's store them in a tileset. So create tileset method. Let's make that now. Create tileset. So we will give our tileset variable a new dictionary to be used with an int GameObjectPair. I'll explain why in a minute. Okay, now we have our tileset dictionary. Let's add the tiles to the tileset. So tileset.add. First will be 0 and then prefab planes. So I'm assigning the prefab of planes to 0. So it's like an ID code, and it's a bit easier to manage than I could do this and have string GameObject, which might seem a bit easier to access, but when I want to set things in an order and I want to iterate through them, it's much nicer to be able to use an integer code. And it's a bit tidier to look at as well. And then we'll add our other 3. 1, 2, 3. Just update these here. So with that done, we now have our tile set of prefabs ready to go, ready to instantiate. So when we use our Perlin noise function, it will return values between 0 and 1, and we can then take that scale, match it with our scale here of 0 to 3, and we'll get nice elevations, as you'll see. Now next, when we click play to create our map, we don't want to spam all of our tile game objects under map. We want to have some kind of organization. So I'm going to create a tile group function here. So what this is going to do, now this is just my preference, but what it's going to do is every time it creates a planes tile game object, it's going to put it under a child here called planes, just to keep things a bit tidy. So with our data set, we'll have another one which will contain our tile groups objects. So let's go ahead and create that method, create tile groups. And you'll see when we run the generation script why that will be helpful. So this is purely for organization. You don't have to do this step, but I recommend it just to make your life a bit easier. So let's set tile groups to a new empty dictionary, like so. Now fortunately, we already have our prefabs here, and we already know the names of them because we've named them correctly. So we can use these names to name the child groups under map. So I'm going to iterate through them. You see, you got the integer values here which help you iterate through them. So I'm going to say for each. So for each entry in the tileset dictionary, we'll loop through them. So this will be, because we're going through a dictionary, this will be a key value pair, a pair of integer and game objects, as you can see. And we'll name that our prefab pair. For each prefab pair in our data set of tiles, so we will create our new tile group, which will be a new game object, and we'll name it the same name as the prefab. So here you can see we've got an integer game object pair. So this is the key, this is the value. So if we do value, which will give us the game object, value.name, which will give us the name. So here we've created a new tile group with the name of the prefab, which will be these down here. Then we take our tile group and currently it's floating loose, so we should stick it underneath our map master object here. So we'll say tilegroup.transform.parent, because when you're parenting something you have to go via the transform and not the game object itself. And here we'll say gameObject.transform lowercase g, so we can reference the game object this script is attached to. So now I'm saying that my tile group is going to be a child of this map object here. Then, just to make sure there's no cheeky offsets coming through, I'll set my transform.local position of, so not world space, but the position in relation to the map parent. I will set this to 0. So we'll have a new vector 3, which is empty. Okay, lastly, now that our group is created, I want to put it into our tile groups dictionary. I want to organize everything nicely. And I want to match the codes of the groups with the codes of the prefabs. So you see we have our pair coming in here from the tile set. So if I go prefab pair.key, it will give me the ID code that I've assigned here. And tile group. So I'm pretty much recreating one of these, but instead of being a data set of tiles, it's a data set of our groups that will match 1 for 1. These two will match 1 for 1 with each other. Great, so our organization here is done. We can get on to generating the map. So we'll make another method here called generate map. Let's create the function for that. Generate map. So let's add some variables for our map. So the first two, which are probably the most obvious, will be the map width. And I'm going to go with 16. So I can do 16 by 9. So my map height will be 9. Now I'm using integers here so I can keep everything nice and lined up, zeros and ones, because it makes me happy. And then we're going to create two 2D lists. Now the first list will store our noise grid, which will be the zeros, the ones, the twos, and the threes to match our prefabs. So I have a nice grid of numbers. And then our second one will be another 2D grid, but of all our tiles. Now I could combine them, but I'm going to do them separately to show you, and then you can go ahead and use them how you would like to. So I'm going to have a 2D list. So let's have a list int. So this will give me a list of lists of ints. So that will give me a nice 2D list. And we'll have our noise grid, which will be the values that we've generated through the Perlin. So we'll set that to a new list of ints. And also we'll have a list of game objects, which will be our tile grid. So our 2D list of all the tiles on the screen. So new, okay, I'm not copying that again. Okay, I'm not typing that again. Cool. So nice and quick, we'll start off with a 2D for loop. So we'll have int x 0. We'll start off at 0. We'll say while x is smaller than the map width. So keep going until we've covered the entire width of the map. Increase the value of x every iteration. So that's just x. Now we need y. So we'll do the same thing for y. Integer y. Keep going until you reach the map height in here. Okay, so there's our 2D loop here. Now if you look here at our noise grid and our tile grid, we have instanced these already. So these are new lists of lists. But that only covers the outer list here. Each inner list has to be initialized individually. So if I go here and I go into the X loop and I go noise grid dot add new list of ints. So if I was to explain that, why I'm doing it like that, if I was to, let's see if I can type this up. So this is a one-dimensional list, right? In our two-dimensional list, we'd have this. We have 1, 2, 3, 1, 2, 3, and 1, 2, 3. So that is a list of lists. Now if we go back here we have instantiated our outer list. So what it will do is go in x equals 0, okay, make a new list to hold all the y values. X equals 1, okay, now make a new list to hold all our new y values for x is 1. X equals 2, make a new list to hold all our y values. That's why we're adding that there. Now, so we also need to add one here for our tile grid. So we'll have a new list, but this one will be a list of game objects. So same thing applies for the tile grid. When x equals 0 in our 2D tile grid list, create a new list to hold all our game objects down the y-axis. Then when x equals 1, do the same. Okay, so now we have our two grids. They're both initialized, and we have all of our locations to put everything. We can now use these x and y values with the Perlin noise function to output some values that we need. Right, so let me just type int tile ID equals get ID using Perlin, and we'll use x and y. So this function is going to output the tile ID that is needed at this x and y coordinate. And I'm going to use the x and y to generate this random tile ID. Now before we go any further down here, let's create a new method called getID using Perlin, and this will return an int. We have int x, int y will be, so the coordinates will be incoming. Now the function we're going to use is mathf.perlinNoise. Now normally you give it these two values, but we're going to change it a bit to give you some customization. So if we scroll back up and we create some new variables, so we'll create a float called Magnification, and this will allow you, changing this value will allow you to zoom in and zoom out, so you get more detailed terrain or less detailed terrain, as if you were zooming a microscope on the terrain. And I'm going to set this to 7. But I recommend any value between 4 and 20. Okay, so now we can magnify. Let's create two others. Let's create an offset in the x. I'm going to set this to 0 to start with, because I don't want an offset to begin with. But I'll give you the ability to offset it. So that will be to shift it left, right, up and down. So just to note, if you reduce this number, you'll be moving the image left. And if you increase this number, you'll be moving the terrain right. And the same with offset. If you decrease this number, you'll be moving it down. And if you increase, you'll be moving it up. So if we go back to our Perlin noise here. Now if you give a Perlin noise a whole numbers, it will always return the same value. So Perlin noise is best used with floats, definitely. So to give you that flexibility that we've just created above, we'll say, okay, the first input will be our x, take away x offset for moving it left and right, and then we'll divide that by magnification, which will count towards your zooming in and out, and the same for y. So y, include the offset, divide by the magnification. And we'll give this a value, so we'll say float, because it returns a float, normalized float between 0 and 1. So float, our raw Perlin will be, now you'll see some when they use Perlin noise, they do x divided by the map width. But I think if you've got x and y coordinates here and they're already being passed through, then I think you don't have to use the map height and the map width. You can just go straight into using them in the Perlin noise. So next, another problem with Perlin is sometimes it does produce values higher than 1 and lower than 0. So we just have to clamp those off to make sure that we are getting normalized values. So we'll do mathf.clamp, and we'll clamp our raw Perlin between 0 and 1, just to like 100% be sure that it's normalized between 0 and 1. Okay, so now we have values coming through Perlin between 0 and 1. But as you can see here in our tile set, we have tiles between 0 and 3. So we need to change our output Perlin values to match the scale of our prefabs here as a 1-for-1 ratio, so we can assign tiles to our Perlin noise. So what we'll do is we will first change our scale. So we go scale Perlin equals clamped times tileset.count. So what that'll do is it will rescale our outputted Perlin values to be the same size as the number of tiles that we want to use. Next, there's the off chance that we might get a value of 4, which won't be very helpful. So we'll say, okay, on the very, very rare chance that scaled Perlin will be 4, set it to 3, because that is the nearest value in our prefabs here. And then last but not least here, we'll say return mathf.floor to int scaled Perlin. So what it's saying is now in my new Perlin scale, which is between 0 and 4, round down that value to the nearest integer. So this will output values 0, 1, 2, and 3. And as you can see, those values match our Tileset prefab ID codes perfectly. And that's the most complex part of this script, because the last bit here is just turning those numbers into tiles. So here, let's save that. So here, now we have our tile ID. Well, we have our noise grid here ready to accept the raw values. So let's just add those in. So we'll say noise grid x dot add and tile ID. So now we're storing our terrain as raw integers. And then last method, create tile using this ID at this position. So let's create that function. Void create tile using this tile code at this coordinate. Okay, so when we're creating our tile, the first thing we want to do is get hold of the prefab that tile ID belongs to. So that tile ID, we can use our ID code here to reference that prefab in our tile set. So you can say tile ID. Cool, so we have our prefab. Next, we want to get our group that tile is going to go into. So tile group is, we've got our data set here of tile groups, so we'll say tile ID. You see how I can use the same value in both of them because they've been organized that way. So I can use the ID code to get the prefab and the group that they correspond to. So let's go ahead and create our tile. So instantiate tile prefab and put it underneath our tile group transform, because you have to put it underneath the transform, not underneath the game object. Cool, so just for organization, we'll say tile.name and we'll give it a name. We'll give it the name of its coordinate. So I'm going to use string.format, which will allow me to use the x and y values here in the naming. So I'm going to call it tile underscore x first value underscore y second value. X and y, there you go. So it will put x into the first one, y into the second one. Okay, so now it has a name. Let's set its position. So tile.transform.local position. Not dot position, because that would be in world space and it would ignore its parents. So we just want it in local position. Say new vector 3 using x, y, and we'll say 0 because we want the whole thing to be on the same plane in Z. And now finally we will add our tile to our tile grid. Add tile. And there we have it. This is the finished code. Now if I just save that, go back here and run it, and we're going to get any errors. Line 50. What have I done wrong? Oh, forgot the colon, semicolon, typical. See, even the best of us get these errors. So line 47, prefab doesn't exist. Why not? Okay, looks like I've missed the prefab here. So that should be prefab pair.value.name, not prefab, sorry. Go back, anything else? Game object could not be found, 59. Yes, so here I'm trying to reference the game object it's attached to rather than the type itself. Save that. Anything else? Scaled Perlin does not exist in the current context. Where are we looking at? Line 78. Here you go, typo as well, scaled Perlin. So I could probably edit out those mistakes, but what the hell, you can see the mistakes I make sometimes. Okay, so no errors, let's click play. And here we go, we have our 16 by 9 grid. Okay, so now we know it works, let's make it a bit bigger. So here I'm going to say 160 by 90, give me something a bit bigger. Let's save that. Okay, if we click play now, there we go. So we have a lovely terrain here. Now if you might notice, if I zoom out too much, you get these shaking. So on your textures here, you can turn generate bitmaps on. And there you go, that will fix that nice flickering. So I'm just using a script I've attached to the camera to move around like this. But as you can see, it's created a nice level of detail. Great, so let's demonstrate the offset and the magnification just to make sure they work. So we have these three mountains here. Okay, so let's go into our script. I'm going to say -10 and -10. So what that will do, according to the comments, is it will shift everything left and shift everything down. So we'll go back. We'll play it again. And as you can see here, these have now shifted from here, 10, 10. And now let's demonstrate the magnification. So magnification is 7. I've tried to use some different values to try and get a nice recommendation for you. So 7 gives you some nice high detail. But if let's say set it to something higher, say 14, which is double. And now we click play. You can see it really changes now. So we've got less detail, bigger terrain, a bit more smooth, but it still looks good depending on your need. Okay, so the last thing to do here, now that we have our finished code, is docstrings. Everyone loves docstrings. Just so we can go through the code again one more time and summarize on everything. So when we start up, we create our tile set. So we have a set of data to access our prefabs. We create our tile groups. So we have a nice way to organize the tiles that are being created. And then we generate the map. So let's go into our first method here, create tileset. So create tileset, what does that do? So I'm going to say collect and find ID codes to the tile prefabs. Ease of access. Best ordered to match land elevation. So this function will collect and assign the ID codes to the prefabs, 0 to 3, to make it easier to access them. And it's best to match the Perlin nicely. It's best to match or order these in elevation. So 0 being the lowest, 3 being the highest. Now other ways you can use this is 0 could be ocean and 3 could be clouds. Or if you've got even more extreme, 0 could be the ocean floor and 3 could be the upper atmosphere. Now the docstring for create tile groups will be create empty game objects for grouping tiles of the same type, i.e. forest tiles. Oh, I didn't actually show you that, did I? So over here, when we click play, you can see here, underneath here we have our 4 children and they are named our prefabs. And then if you look underneath there, you have all our tiles and they are named X and Y and then where they are located. Now you can organize this any way you'd like. I've just gone in and used the name of the prefabs to create them here and name them for me, nice and simple. So here, let me just close that one. Create empty game objects for grouping tiles of the same type. So it will go through, it will take all the prefabs that we've collected in our tile set. It will take the names to make groupings, which you can then use to group your tiles. Okay, next doc string will be generate map. So how should we describe this? Let's say generate a 2D grid using the Perlin noise function, storing it as both raw ID values and tile game objects. So here we're using Perlin noise in our generate map function to generate the tile IDs, and then we're going to store that as a grid of all the numbers, and then we're going to store that as a grid of all the tiles as well. Okay. Next function here, we'll go with get IDs. Okay, so for this function, using a grid coordinate input, which will be from our 2D loop here, x and y, generate a Perlin noise value to be converted into a tile ID code. Rescale the normalized Perlin value to the number of tiles available. So what this will do, this will, using the coordinates that are incoming here, it will create a raw Perlin noise value, it will clamp it off, it will scale it to match the number of prefabs that we have, so we have a 1-for-1 scale. It will remove any outliers, which should never happen, but just in case. And then it will round off the Perlin scale, so we now have a tile ID that we can use. Okay, last function, create tile. Let's give this a doc string, and we'll say this function creates a new tile using the type ID code that's coming in. Group it with common tiles, set its position, and store the game object. So what this will do is, given the coordinates I'm being asked to create the tile at, and using the ID, instantiate the tile, group it with the common tiles, set its position, and then store it in the tile grid list. Here, 2D list. And there we have it. And you can do any size you want. If you don't want 16 by 9, say you want, 50 by 3, that will still work for you. There we go. So I stick with the 16 by 9 ratio here because it matches the screen, but whatever works for you to give you this lovely terrain we have here. Cool. So I hope you found that useful, and if you'd like to help me out, please like and subscribe if you want to. And thanks for watching. I really appreciate it. But yeah, awesome. See you next time.